Namaste everyone. Today we are going to discuss the topic Be-Broglie's hypothesis. We know that light has got wave nature. That means the phenomena like interference and diffraction shows that light has got wave nature, whereas the phenomena like Compton effect, photoelectric effect proves that light can be explained in terms of particles like photons. So we can say some phenomena like Compton effect and photoelectric effect proves that light has got particle nature. So I can say it has got dual nature, that is both wave nature and particle nature. This wave particle dualism of light was further extended by Be-Broglie in the year 1924. Yes, the wave particle dualism of light was further extended by Be-Broglie in the year 1924. He suggested that light waves, if they behave like particles sometimes, then particles like electrons, protons, neutrons, atoms, molecules should also behave like waves. This was the idea given by him, which had no proof at that time. Hence, it is also called as hypothesis, and it is named after him, that is Be-Broglie's hypothesis. Now, let us see what is Be-Broglie's hypothesis. Let us consider a particle of mass m. Yes, if m is mass of particle and it is moving with velocity v, then this particle is associated with wave. This particle is associated with wave and this wave is called as Be-Broglie's matter wave. Okay, any particle, if it is moving with some velocity, then it is associated with wave, or I can say it has got wave nature, and that wave is called as Be-Broglie's matter wave. Okay, then the wavelength of the matter wave is given by lambda is equals to h upon mv. Okay, where lambda is the wavelength of matter wave, h is the Planck's constant, m is the mass of the particle, and v is the velocity of particle. As we know, mass into velocity is momentum. This equation can also be written as lambda is equals to h upon p, where p is the momentum of the particle. Now let us see how this equation has arrived. We know that according to Planck's quantum theory, the energy of photon is given as E is equals to h nu, can be also written as hc by lambda. Yes, energy of photon is given by h nu. H is Planck's constant, nu is frequency of photon. Frequency can be written in the form of wavelength, that is c by lambda. And according to Einstein's theory of relativity, we can write it as E is equals to mc square. From the above two equation, I can write, yes, hc by lambda is equals to mc square. The c and this c getting cancelled, and rearranging this equation, I can write lambda taking on this side, mc taking on this side, I can rewrite this equation as lambda is equals to h upon mc. Okay. Now this is true for photon, that is light photon, where m is the mass of photon and c is the velocity of photon. So if this is true for photon, then we can consider any particle of mass m moving with velocity v. Then if it is associated with a wave, then it is associated with a wave, and the wavelength of matter wave can be written as h upon mv. Yes, similar to this equation, I can write down the wavelength of matter wave as lambda is equals to h upon mv. Now, as the particle is moving with some velocity v, it is associated or it has got some kinetic energy, and we know that kinetic energy, or simply I can write E is equals to half mv square. Okay, taking 2 on this side and multiplying both the sides by m, I can rewrite this equation as twice me is equals to m square v square. 2 taking on this side and multiplying both the sides by m, I can write this equation as twice me is equals to m square v square. So this will be p square is equals to twice m e. Mass into velocity is momentum, and therefore p square is equals to twice me. Therefore p is equals to under root of twice me. We know that the wavelength of matter wave is written as lambda is equals to h upon p. Substituting the value of p, I can write h upon under root of twice mv. So this is another form of equation for wavelength of matter wave. It can also be written in this form: lambda is equals to h upon under root of twice me, where m is the mass of the particle and E is the kinetic energy of the particle. Now, if the particle is at thermal equilibrium, then applying the kinetic theory of gases, the kinetic energy of that particle is given by E is equals to 3 by 2 kT. Okay. Yes, I repeat, if the particle is at thermal equilibrium, that is at constant temperature, then according to kinetic theory of gases, the kinetic energy of that particle is given as E is equals to 3 by 2 kT, where K is the Boltzmann constant and T is the constant temperature. So this equation can be written as h upon under root of twice m, putting the value of E as thrice 3 by 2 kT. Okay, 2 getting cancelled, and therefore lambda is equals to h upon under root of thrice m kT. Okay, where lambda is the wavelength of matter wave, h is the Planck's constant, m is the mass of the particle, k is the Boltzmann constant, and T is the constant temperature. Now, if we want to determine the wavelength of electron wave, that is, if this particle is nothing but an electron, then we can derive the wavelength of electron wave. De-Broglie's electron wave. Yes, if a particle of mass m is moving with velocity v, then that particle is associated with wave, and that wave is called as De-Broglie's wave. And if that particle is electron, then that wave is called as De-Broglie's electron wave. Let us consider an electron of mass m, and it is accelerated by a potential difference of v volts. Yes, v is the accelerating potential difference. Yes, if I consider an electron of mass m and it is accelerated by a potential difference of v volt, then its kinetic energy is given as E is equals to E to capital V. Therefore, I can write this as half mv square is equals to EV. Taking this 2 on this side and multiplying both the sides by m, I can write this equation as m square v square is equals to twice MEV. Therefore, P square is equals to twice MEV. Therefore, P is equals to under root of twice MEV. Yes, we know that wavelength of matter wave is given as lambda is equals to h upon P. Putting the value of P in this equation as under root of twice MEV, lambda is equals to h upon under root of twice MEV. This is the equation for wavelength of electron wave, where h is the Planck's constant, m is the mass of the electron, E is the charge of electron, and V is the accelerating potential difference. Yes, putting the value of Planck's constant, that is h is equals to 6.63 into 10 to the power minus 34. Putting the value of mass of electron, that is 9.1 into 10 to the power minus 31. Putting the value of charge of electron, that is 1.6 into 10 to the power minus 19. Okay, we can solve this equation and get the final answer as lambda is equals to 12.27 into 10 to the power minus 10 upon under root of V. Yes, putting the value of Planck's constant, mass of electron and charge on electron, we get this equation, that is lambda is equals to 12.27 into 10 to the power minus 10 upon under root of capital V. This is in meters. Okay, so I can write this as lambda is equals to 12.27 upon under root of capital V Armstrong unit. Okay, so this is the wavelength of electron wave. Okay, so in short we will revise the equation for wavelength of matter wave. It can be written as lambda is equals to h upon mv. That's the first equation. It can be written in this form also, h upon p. Yes, again de-Broglie's matter wave can be written in terms of kinetic energy, that is lambda is equals to h upon under root of twice me. It can be written in the form of Boltzmann constant and temperature, that is lambda is equals to h upon under root of thrice mkt, and the wavelength of electron wave can be written as lambda is equals to h upon under root of twice MEV, or putting the values, it can be written as 12.27 upon under root of V Armstrong unit. I repeat, lambda is the wavelength of matter wave, h is the Planck's constant, m is the mass of the particle, v is the velocity of the particle. In this case, mass into velocity, it is taken as momentum. If I want to write it in the form of kinetic energy, then wavelength of matter wave is given as h upon under root of twice me, where E is the kinetic energy of the particle. If we consider the particle at a thermal equilibrium, that is at constant temperature, then wavelength of matter wave lambda can be written as h upon under root of thrice mkt, where k is the Boltzmann constant and T is the constant temperature. If we consider the particle as electron, and if it is accelerated by a potential difference of v volt, then wavelength of matter wave is given as lambda is equals to h upon under root of twice MEV. By putting the value of all the constant, I get the final equation 12.27 upon under root of V Armstrong unit. Thank you.